I just wanted to remark about this. I have something to say about this one remark here. The indeterminacy of the quantum description of the atomic world is not an artifact of missing information that could be provided by some new larger theory of the world. I'm not very happy with that remark, but what I wanted to say there, what I think is what he's saying is that if you've got something like a murder mystery and you've got some evidence, gathered evidence, then the investigator or the court makes sense of that evidence. What does that evidence tell you? What happened in that situation? How was the person murdered? How did it happen? What happened? So then a story emerges. You make sense of the evidence. And in science that would be measurements and observations. You make sense of it and you say, okay, that's what's happening. Now, if new evidence emerges, that could change the whole interpretation of the other evidence that was already gathered. So that's the missing information. If missing information or new evidence comes to light, then the whole interpretation could change. And what he's saying here is there's no missing information, which means that the scientists have explored all avenues, and they believe whatever we could measure or observe was all the evidence is there. There's no missing evidence, which means that if you want to explain this in another way, you'll have to work extremely hard. Usually what happens is you develop a new theory which explains what happened there in a different way, but it also helps to solve other problems, other observed phenomena which couldn't before been explained. So you have to make a theory that goes wider, like for instance Newton did with gravitation. His gravitation didn't only explain what happened here on Earth, but also what happens in the heavens with the planets and whatever. So the theory has to be very extensive then. Okay, I thought I would go very quickly through chapter 1. It's gonna be a bit ridiculous, but it's something about atoms and matter. So let's just quickly page through it and see if we can get something. Talking about the whole universe, everything in the universe, and some people thought about this idea of the atom, single atoms, and that's 11, 12, atomists, Aristotle, Epicurus, and so it's about history. Robert Boyle, bodies, Newton, Earth, elements, 4 elements, earth, air, fire, water. So people who thought about it and maybe did some experiments and investigations trying to explain what is happening with matter. And Lavoisier, chemistry, substances, alchemist, gold, lavoisier, air, fire, water, ether. So it's an overview of what happened with the investigation of matter in the past. Some chemical elements, identified elements, how to identify there are such elements in matter. Elements, atoms, chemical reactions, caloric, that's something about heat, proportions, atoms and molecules in Dalton's new system. So the atoms assemble to make molecules, electron cloud, Mendeleev, arose with excessively heavier elements, same chemical properties. So that's the chemical table. There's the table, periodic table. Electron, that's some subparticle in the atom. Charged particles, electron, electricity, and some evacuated tube. Plum pudding model, Rutherford atom. So what is going on inside of the atom? Nucleus, cloud of electrons, lead block shield, there's radioactive material there, Rutherford spectroscopy, Fraunhofer, it's spectroscopy. Planets and stars, what is that there? Nanometers, formula, wavelength, N and M, numerical, integer based, molecule, incandescent gas, planet orbiting the sun, and joules, that's energy. And now atomic lines, so that's spectroscopy. What is going on here? Atomic lines, atomic structure, atom structure, spectrum. Under certain conditions you get that the elements form, emit light, discrete emissions. So something that's referring to waves, wavelength, Fraunhofer. Okay, how the atom is constructed, chemical properties, electron. Elements are made of extremely small particles called atoms. Analytical chemistry and property of atoms. Okay. I'm going to do something quite ridiculous. This is page 10. So I'm going to choose 3 words on this page. Compounds, gold, substances, philosophy, matter, shapes. Shapes determined by the properties of matter. Okay, substances. Diverse substances. So that's refers to in the world there are various types of substances, or various types of properties. Philosophers, small particles of matter. Small particles of matter. Distinct properties. Like hard matter and soft matter and fluid matter. So they've got different properties, and here it also shapes, something about shapes. Okay, enough of page 10. So what does page 10 talk about? Various substances. These substances consist of small particles of matter, and these small particles have the properties of matter, and then something about shapes. Okay, that is page 10. Now page 11. It seems they're talking about locked together in the bars and mass construct empty space atoms linked patterns. I think it's talking about these particles of matter combine to form other pieces of matter with other properties. I think it's something like that. Shapes, again it's shapes. Half empty box, locked together, atoms locked together in a vast immovable mass for eternity. Particles combine, shapes. So it talks about they combine to make new types of matter, I think, something like that. 12. Air, fire, water, ether, atoms. Theory of atoms. Aristotle's earth element, gold, atomist. It seems they're talking about the various theories of matter, like this earth, air, fire, water, ether, and then some people thought, no, it's atoms. I think that's why it's referring to atomist. So there's the various views of matter. Newton proposed atoms interacted among itself through non-gravitational forces. So it's the various views that exist in history. Atomist. People who thought matter consists of atoms, and those who thought no, earth, air, fire and water and ether. That is 1, 2, 3, 4, 5. 5 elements. And that explains what matter is. Page 13. Yeah, Aristotle's 4 elements: earth, air, fire, and water. Basic elements of matter until the 14th century. Some diagram. That's water, air, and that seems to be fire. Ooh, how they interacted. That's Aristotle. Earth, air, fire, and water. So they're struggling to understand the various theories, what is happening with matter, movement of bodies, gravity, atomic model, chemist, alchemy, gold, crucibles, compounds. So these are trying to change matter, the chemical reactions. Module. Aristotle's compound substances, gases, oxygen, Lavoisier, beheading, French Revolution. Goodness gracious. I didn't know that Lavoisier was beheaded in the French Revolution. Systematic listing of some 33 elementary substances. Lavoisier. Elementary substances. Maybe I identify them due to the chemical reactions and saw that they react chemically different. So it's the story that emerges here is that matter, atoms get different properties when they react with each other. They react differently.